Oh, volume's turned on today. All right. So to recap where we left off the other day, we were talking about those Claisen condensations. So the Claisen condensations, when we had two esters, and we let the esters react, we turned one of the esters into an enolate to then act with the nucleophile on the other ester. Right. So our most common way to do this, the way that's most reliable, you can use an ester that doesn't have any alpha carbons, like the red one here, but that basically limits us to either benzoates or formaldehyde based, or I guess it'd be formates. Very limited. If we want to do it more universally, we just have to do it sequentially. We have to irreversibly make our enolates by exposing one of our esters to LDA or NaH, either one works, to make the enolate and then bring in the red one, right? And that's going to allow us to have our enolate act as the nucleophile, we make that tetrahedral intermediate, and we kick off the red leaving group and reform the carbonyl to get a ketone and an ester linked, where you get the alpha carbon from the blue ester to the carbonyl carbon of the red ester, what was ester. So let's do some more practice with these. So what reactants would you use for each of these? That's, I didn't prop it properly.
That's so sad.
I can fix that.
Well, we gotta figure out how we're gonna try. Oh, I think. So that's part one. That is gonna be one of the what's that? I checked the mix for most of mine. I got to a point where I was like, I found the that I might be sure, like I used to support my it was. I guess we're something studied enough. I did put one right when I was 1999. Yeah, all of the first ones were delivered that I found last week were like 80s. Yeah. Isn't there an order on this? Yeah, see, if you're doing the. Yeah. Um, Wait, so how, what did you do about arrow? What is that? Why did you put it on your arrow? So then, wait, so then it, yeah, if you put the LTA, you need an order on one drive. Yeah, because all that doesn't make a big difference. Yes, this what? Yes, not the babies. Where's there are the leaves? Right there. No, your other one needs an order too. No, it doesn't, it's the men's here, look, all of them are gone. Yes, that's, look, gone. No, if you're doing that one with LD, that one stays. Oh.
Okay, the one that stays as an ester is the one who's the enolate.
Yes.
So this
This.
was the enolate. In fact, let me get my color coded.
Guess what? We're like, I never understood this class. Well, we made it a pretty long time faking it.
The classic example of fake until you make it. It's the correct response to imposter syndrome is you just keep
Yes.
pretending until you really do understand.
I think we don't even know how I taught. Going on and clear and yeah.
Because you understand it better than you do self-driving.
That's true. I feel like we always understand it more than we do because we always want to understand it like up to deeper level.
Think about how you were confused, how confused you were just talking about SN2 reactions back in somebody. Okay, so the red one is going to be our enolate. So this is what we're going to start with.
See, you had it gone then in your arrow. No, I didn't do such crap. Which one did you do? Ignore that. And then LT.
Plus LDA gives us our enolate.
Is the negative always gonna go just for everyone?
The
Yes.
negative is always going to go on an alpha part.
Oh, right. I like red as. It's like when we drink water and
We just water comes and goes. That's fine.
and I use it to do whatever I want, even if it makes no sense. Exactly.
Okay, so now the question is, what did we have to react with that was blue?
That with an OR.
Exactly. What's the R though?
Does it matter if we have to say?
If
I put R. Okay.
it could be anything, make it the same as your other weekly kernel.
Got it.
Just because as you have a leaving group going around, you might as well be the same leaving group, because otherwise, if this is a methyl group, a methoxy group, then you wind up with a side product where your methoxy group could attach here. And then you replace that, and so you wouldn't get as good of a yield of this.
Yeah.
So when in doubt, make them the same OR as what your desired product. Right, so then what's going to happen here is, and if we're actually going to show the whole step, the whole mechanism, which we might as well for practice. Now we don't have we have a tetrahedral carbon now that has the OET, then our new bond, then our red molecule. All right, so then the last step is that leaves, this reforms the carbonyl.
I keep mixing up my colors. Okay, take a breath.
didn't do this intentionally, but I have to wear a Band-Aid, wear a cloth Band-Aid. It actually makes a really convenient little mini eraser.
Good trick.
I wish I could say I planned it.
What happened?
I just got a hangnail and I tore it open.
Those hurt so bad.
They do. They heal quickly, but they're not fun. So then final product, just gonna need that, just redrawn with our color coding.
Look at you not playing with my hair. See, I was just playing with it actually. I just went to grab it and then you whipped it around. Because it's not as long as the curve anymore. Okay, but it's just, it's wet. It's not. It's all gone. It's not on the track. So good together.
So
I was literally looking into like professional curly hair last night. I was crying about it. I was like, oh, I'm going to be crying before my birthday.
what upside to this, don't have to go through getting a haircut again for a while, forever.
I'll do it again. No, you not.
All right. So with that, I'll leave that up on the board. You all do me.
Okay. You want us to do the full thing?
I think it would be good practice.
No, I'm gonna take great care of my hair. I never, so that I'm never gonna need hair ever, ever. You'll have to be creative today. Okay. I think it's that. Yeah, I think so. But now, so the one that keeps is the is the one that was. Right? Words, yeah, correct. He's over. How the freaking year I got my car? It started with hey, let's use our nice words. You kind of have no nice words for you because I have. It looks fantastic. You should have all the nice words for me. Next cover. And you know that I didn't read this. It's such a good game about it. So nice. I used too much. Like I used too much of course. Oh, rub it in there, and I'm like, oh my god, I'm so ready. So do you want to rub it in again? No, you like the conditioner is confusing. So it makes sense. So like, is it working? Is it in? But I used too much like this. I didn't balance like that. Or even enhance. And make it very short. And then it's like that. I have a break it to you. I did only see this, so it seems like all my memory is short. No, but look around again. It's so good. But it's also. Yeah, it is. I
It's
just.
never gonna be that curly because you don't need, it's being weighed down by the rest of it.
Well, I just see this, so like all of my hair is all that short and it's being over. I worked years to get my hair done. It's almost my butt.
All right, so there's our two.
Yes. Yeah.
This one looks funky.
Yeah, this one, that's why I kind of stopped for a second, because
Just another way of saying that.
okay. So but then so our alpha carbon would be the tertiary one.
So our alpha carbon is, yes, it's the tertiary one. So our red molecule is going to be it's drawn more spread out, so it's more like what we're used to. And if we were naming this, so we can never forget about our nomenclature, how do we name esters?
Don't we just like add extra to them?
Name it like it's the acid, but you drop the ic acid and you put 8. And then whatever's on the other side of the ester is a separate word.
Oh, this is one with the
This is
space.
the one with the space. So this would be
Cause it ate the egg.
exactly
Ate the egg.
methyl pentanoate. Right, so the methyl pentanoate gets exposed to LDA. Then we let it react with we just have 2 carbons. And then we had a leaving group attached. Let's make it the same leaving group. So methyl acetate or methyl ethanoate.
If we draw it like that, do we lose a carbon? On the loop?
No, because this has 2 carbons. We're gonna, I mean, I guess yes, but as a methoxy.
Where is the negative gonna be on the? I don't know.
Okay, so these are really the same. It's really similar to the alcohol condensation, the way we approach this. Find your alpha carbon and you find your active carbon, and you circle both of them. Color coding really does help keep things straight. The only difference is with the Claisen condensation, we end up with something that still has 2 carbonyls. It's just one's a ketone, one's a ester. Versus the alcohol condensation, we wound up with one of them as a ketone and the other one as alcohol as our final product.
that after you will be forgiven again. But like you predict. That's what I. Actually, no, this was there. This goes here, and it's so and oh.
That looks more right to me.
But you're what it means. No, it's just this isn't a branch. It's just
It's strong funky. So the red one gets exposed to LBA. Which is going to put a negative charge. Here. All right, how do we feel about this?
okay, they're not the worst for sure. I feel like if I had one example of your favorite, like I do them all.
Exactly. That's why you get a page of notes, right?
Yeah.
We've reached the point where none of the mechanisms individually should be that scary. It's just that now that we know so many of them, it's hard to keep track.
Yeah.
It's a little bit like doing your vocab for the SAT. And none of the words individually are that tricky,
Right,
but as a whole, yeah.
What did you do?
All right. Now there's a subclass of clays and condensations.
Okay.
It's really nothing we haven't done already. We did this with the aldols. Remember we did all this cyclization reactions with the aldols. This is just if you do it with a Claisen condensation, for some reason they thought it needed another name. So we get the Diekmann cyclization. And with all cyclization or ring opening reactions, the trick is count your carbons. Right? Because it's going to be the alpha carbon from one carbonyl reacting with the active carbon from the other. And we really only see this if the alpha carbon is either 5 or 6 carbons away from another ester. Right? If they're closer than that, then there's too much ring strain. If they're further than that, then it doesn't make us stable enough. It's also strain energy. It's just different strain energy. We don't like 7-sided rings. We don't like 4-sided rings.
You made a strong 7-sided ring out.
I have. They can be made, but they don't. You have to work at it.
Yeah, you have a strong one on an exam. You said you like.
I do. Just once in a while.
Well, I
Symmetry.
decided all of the box, so I pulled that tape, the little thing out that you can like trace it. And I said, here you go.
That's why it looks so good. That makes sense. All right, so in this case, and again, the trick is even though there's a total of 6 carbons here, it's the alpha carbon that's reacting. So it's carbon 2 reacting to carbon 5, which means we're only going to get a 5-sided ring plus an ester group hanging off the side. And as we'll see in a few minutes, if we make something like this, this is pretty easy to convert to an acid, right? If you wind up with something that is where you get an acid that is where the alpha carbon is stabilized by another carbonyl, it's actually really easy to just remove that whole group just by heating it, by going through decarboxylation. So this actually allows us to start from something like this and turn it into cyclopentane. A pretty simple molecule. So it is actually more useful than you would think because it allows us to take straight chain molecules and irreversibly make stable ring structures. But let's practice with this first. Predict the product when we get a Diekmann cyclization. Again, the reactants for that is going to be the same as our place in condensation, which is just a base. All we need is the base that's strong enough to pull off an alpha carbon hydrogen. And in this case, because it's reacting with itself, we don't need to use LVA, we can just use sodium methoxide.
Same version of all of those. Jeez. This one. For apples, 101. What is the one? Can you do that on Thursday? If we get our exam on Thursday?
What's that?
It's not only she already with minutes. She's our emotional support note writer, guys.
It's true. It's true.
If we don't have class Thursday, I need to get my nails done right at the beginning. You can do that and I need some. So I have to go in the morning. Maybe it's like smooth. She'll be up and. So
She will be out for finals week.
I know this because the girls that I coach are going to be a daily count.
Yes. Are we at 8 days, I think now?
I think so, yeah. We're pretty accurate.
Or Dash is still doing iReady testing.
Oh, no.
Just like the statewide standardized testing. Because he's in the two-way immersion program, he has to do the Spanish one. Nobody else has to do the Spanish one.
And your family guy.
Well, the whole family, nobody else, only about a quarter of the kids at the middle school are in that program. So 75% of them are like just watching movies, goofing off. But the Spanish speaking kids have to be taking more tests.
Are we adding a bond?
Yes.
Okay.
Between alpha carbon.
And see, I told you it was that one.
1, 2, 3, 4, 5, 6.
No, it didn't.
It is too many that we would normally expect to see this react because I made a big deal out of either 5 or 6. But this one specifically says, well, what if it did?
Right. That it might be for yeah, hold on, give me a second to figure it out. If that's so. Do we still have?
So it looks wonky.
Mine looks like it's
I bet your auto recognizing shapes iPad is not, really doesn't like 7-sided. Hexagons and pentagons, it'll do, but
So one of the OET groups goes away.
one, yeah, just like the blazing comets, just like the reaction we just did, which happens to be that both our alpha carbon and our carbonyl carbon are on the same molecule, so it makes a ring.
Nice little piece. I don't care what you want, Riley. Sorry, don't shoot my hair, you just come. How about I think we do? Actually, someone else.
She'll be hanging out on graduation day too, in all likelihood. She likes to help out.
Yeah, we should do like a pizza party over in summer because then we got our teacher and it's fine. Sure.
We might call one of you two to see if you're interested in doing a little babysitting over this spring. Actually, maybe both of you, because Laura's family's coming and there's more small kids. There's a bunch of them. A 3-year-old, a 5-year-old, and a 13-year-old, in addition to our 3.
Love your dreams.
But
A lot of
the
children.
teenagers will take care of themselves. So we might call you after graduation and see
Go for it.
if you're interested, so that the adults can go out there.
Well, no, we have the other one that are. So it's a little take like. Yeah. Rather than like sooner, or sooner, you don't know, you. I know how to work for it, where you have been through the process. And then walk away. So yay. I can't give my idea and myself. Yes. Is it a fourth factor? It's 5.
5.
Oh, because you add one.
Alpha carbon goes all the way to carbonyl carbon. Then you count those, it's 5. And so since the side where the alpha carbon is doing the reacting, the rest of it's not changing, I left that mostly in the same spot, and then I bent the rest of it over that one. And the carbonyl carbon remains a carbonyl, we just take off the OET.
I would say these ones are my favorite. I mean, if you keep your numbers going, what's important, like, if I just have like this, and then I remember, like, we have it's 2, 3, 4, 5 plus, then you know 5 of these things on this. And 1 of these things.
It is still methodical, it's just you have to be careful. I almost always would write out the numbers, because I'm gonna lose track if I try to do it all in my head too.
Yeah, okay. Oh, it's just, okay, it's just, you know, having OCD, I guess, but maybe when you're doing. Well, you're not gonna. It's just like, the only one who can the whole thing.
I'm not saying that neurodivergent people are more successful at science. I'm saying there's a lot of neurodivergent people in the sciences.
Wait, can we number them? Don't just do this.
Yeah, we'll number.
You number them.
Try it first.
You know how to count. Maybe not past 4, but you can do it. It's just. It's okay, center-sided paper.
It is.
What is?
No, it's not. Only have 6.
Font?
There's only 6 carbon stuff.
I was counting the carbons of them.
It does look bigger than that. I thought so too at first, and then I recounted. And so. I'm gonna keep 1 and 2 and 3 in the same spot that they are, so that I can do that. So this is 1, 2, 3, 4, 5, 6. Connect 1 and 6. 6 has a carbonyl on.
What about the dimethyl?
Then we go back, that was on carbon 3, right?
I guess. Ah, I want that.
So be methodical, count your carbons. And remember, it's the alpha carbon on one side reacting with the carbonyl carbon on the other.
And this is gonna be an AOET or HCO for us.
It's gonna be whatever your R group is, your OR. On your ester is going to be the same thing you use for your base, so that you don't get competing
So-
reactions.
Oh, is it always gonna be NA?
No, because depending on the size of the base, that has more to do with whatever you have in your stock room. We don't care about what the counter ion is. We just need it to be there, and typically you get the larger your base is, the larger your ion has to be. So we use TBUOK because T-butoxide is bigger. That's a larger molecule, so we need a larger counter ion, basically to make a more stable crystal structure. More stable crystal structures are when these are approximately the same size.
This standard indicator with of NA, right, like X.
Typically, as you use N for metal,
Great.
X always means like halogen. Yeah. Not in this case, not if we get in the melanic ester phase.
Gonna be O3, or H0 plus.
Then we follow it up with some H3O plus just to neutralize the acid. Although you don't need that step because if you do neutralize the base, then you run the risk of this being converted into an acid. So depending on where we want it, if we want it to stop at the ester.
Yeah.
We probably, if we're gonna add much acid, it's gonna be very little. So I'm actually more in favor of just leaving it. It just is followed by an acid workup, but that's just enough to neutralize. But it's not strictly speaking this. You can leave it on basic conditions.
Yeah. I could not, like. Yesterday I was trying, like, I didn't even mark with all the way, I could not find things, right, by the time I was like putting them on my feet, I could look at so many words and stuff, or my eyes were everything, and I could not spell. Like, I was, like, it said like fell below, and I was saying. Following below, and I just. Kept putting like FO, it's like FA, like, so I was trying to say falling below, and it just kept being like follow away, and I'm like, this is a great word, how do I spell? But this is, for like saying why I like this article. Falling below this, what this is. Yeah.
Predictive text actually really messes with me sometimes.
Right, cause I was like, cause then I was like, Googling, I was like, fell as. Like following, and I went falling, and it's like not, my brain is not working.
All right, so a few more slides, and then we'll take our break. And then Taylor, what we were talking about before you got here is this set of slides is the last stuff we have to cover. And we still have 2 more lectures to do it. So I'm okay with us using the second half of lecture today in place of lab to just talk about your research articles. And then you're free for afternoon.
I said so good about it, but you said no.
So that there's no need.
Yeah.
That way you can enjoy your science speaker.
Yes, you speak?
I had to bike here. I don't have lab, but I had to bike here today because I had to drop Laura's car off to get the brakes done. And then I also have to get dashed to baseball practice by 5. So I think I'm gonna use that time to go bike to the mechanic shop and pick up the car.
I just drive you to your car, and if I can fit in my car, you can come to the line, but that's illegal right now, you have to wait another 3 weeks.
All right.
The last reaction that we're gonna talk about today is if we wanted to add an alkyl group to the alpha carbon, it'll still work the same way we've been doing. We can still make an enolate and then use it as a nucleophile. It's just in this case, our target for the nucleophile, instead of being another carbonyl molecule, it's an alkyl halide. No, it's a substitution reaction. It's a substitution reaction that allows us to link two carbons together.
Are you trying to understand the first order? Is it always going to be a gray?
No,
Okay.
anything with an alpha carbon can be turned into an enol. Anything with a hydrogen on the alpha carbon can be turned into an enolate. And any enolate can act as a nucleophile if we have something that has a halide as a leading group.
Reaction process you.
To link two carbons together. So it's actually closer to a Grignard reaction. Because a Grignard reaction allowed us to put a negative charge on a carbon and have it act as a nucleophile, right?
Yeah.
Alpha carbons can do the same thing. So if instead of, so remember for a Grignard reaction, it would look something like, if I had this, I could expose it to magnesium and make a Grignard reagent that looked like this, which is going to act like there's a negative charge on that carbon and it could be a nucleophile. So this does something really similar in step one. It's going to put a negative charge right there. It's just, this is a little bit easier in some respects because we don't need to worry about water getting involved as much. But we also have to have a carbonyl in order for this to work.
Okay.
So try drawing mechanism for this.
We always need to do this. We're not that smart. They used to be given to us. Sean.
Well, I've already done the mechanism for making an enolate several times today.
But I believe in this.
I believe in you too.
You can get There's been my moments, but I get this. Let's, we're gonna do ours being today. Ours, I don't know. Right. Do we?
Let's make it a folder.
Okay. First, we do LDA.
First do LDA.
And product mechanism we draw everything, right? So yes, needs like I don't know that. Cool. Should be like moving the R X X. X I don't think room. Anyhow, roaming for impact, I understood the age group. But the negative, I was focusing. The negative would tap the methyl group because the methyl group is gonna have a pressure plus. And that's gonna make it the one go to the bromine. That is space the agent. Okay, what's the other? Well, we must have been trying to have it as an H. That's when we just want the H. You don't just want the H. I think I did it. I'm genius.
Okay, good.
Oh, thanks.
So the LDA,
Your career is never gonna be here. Hey, there. I didn't know this actually, I know that works.
well, if I was actually drawing out the structure of LDA, we just need something that has a nitrogen with a negative charge on it. So LDA is lithium diisobutylamine. So it would look like
We did do that. I just. Let's.
Yeah, LDA is, the L is for lithium, and the D is for it's either diisopropyl or diisopropyl, I don't remember which. But doesn't really matter because the most important part is the nitrogen for the amide part.
Right.
Because that's gonna act as our strong base to make our enolate. Now this can react with our methyl halide. Actually, I'll draw it out. I'm gonna use methyl iodide, but it doesn't matter. Methyl iodide is commonly used because it's a solid at room temperature, which makes it easier to use. It's just gonna do a quick SN2. Iodide leaves, we have the CH3 group.
I do want to.
Yes, plus your leaving group is now left.
Is there. Used to be. Might be charging the air. That's quite often the correct. I noticed I was using that. Well, like it's some just like used before, but when I just because every time people say this, about that's differences. I live in Bruce. Yes, very safe. That's why we go. What? That's what I think of every time. And no one
Okay.
predicts it when I say it.
I do not remember that scene. I think I had that on in the same room as you before, right?
It's like for her wedding, and it's like he just does a bunch of fun basically, and she looks in the mirror and she's like, "What the heck? This looks so bad." And he says, "Wow."
All right. The last thing about this before we take our break. If we have an asymmetric ketone and we try to make it into an enolate, we talked about how most of the time we're going to get the more substituted enolate. It follows the 8 steps rule, but it actually is a case of thermodynamic versus kinetic control. The thermodynamic product is the one that we're going to get if we give it enough time and energy. Is one that follows the 8 steps rule. We're going to get the enolate on the more substituted carbon. However, if we do this under kinetic conditions, which remember means cold, right? We get kinetic product if we don't give things enough energy to get over the higher barrier. So at low temperatures, we have enough energy to get over the red barrier, but not the blue one. So low temperatures are going to favor the kinetic enolate, which is the less substituted one. For a couple reasons, it's kinetic. One, due to sterics, which is always our go-to when we're not sure, right? It's to think about sterics, but also because this gives us a negative charge on a less substituted carbon. Carbanion stability is the opposite of carbon-cation stability.
Okay.
Carbocation stability says the more substituted is more stable. Carbanions that's backwards. So the less substituted is a little bit more favored under kinetic conditions. But 8 steps rule, making the most substituted alkene takes over if we give it enough energy to get over this blue barrier. Right. So what that looks like is, in both cases, you can either use LDA or use sodium hydride. But we're going to either have to do this at dry ice temps, or if we do it at room temperature, we're going to get the 8 step product, the thermodynamic product.
But either of these bases works in either conditions.
What if it's not specified?
If it's not specified, assume it's at room temperature. So that's why we started with assume you're gonna make more substitute. However, we can trick it, basically, can game the system by making it really, really cold. Practice. And then this is all for today.
It's what?
I don't know.
Okay. Wasn't it like a late winter? Whoa.
I think we might have had some snow days, and I might have had to cancel some more classes for illness, either me or my kids.
A late winter last year.
It could have been a late winter last year. And also we had Juneteenth falling on a Thursday, so I had to be a little bit ahead of schedule to plan ahead for that. This year Juneteenth on Friday, means it's not an issue.
So at low temps, it's kinetic.
So start by making the enolate so you can see. Low temperature, put the negative charge on the less substitute carbon. And then step 2 is methyl iodide. So we just add a methyl group where the negative charge is. Piece of cake.
That didn't set, just through. No, just a few different problems. And purpose. Oops. Never told them it goes back. There's so much. Yeah. Before you're done. You have no links and then.
So the movie quote that gets stuck in my head is anytime somebody says piece of cake,
Yeah.
I can't help but follow piece of crumb cake from the 1990s Casper movie with Miss Machine.
There's the exorcist who comes in at the beginning.
Yes, yes.
No problem, piece of cake, piece of crumb cake.
I've seen that movie, but it's so bad.
One of Laura's favorites.
Where did she go to get her haircut?
I don't think you could ask her, but she doesn't have one that she likes. She always goes in and goes through the same freaking process.
You just told Zoe
Yeah.
this. Right, so we just went to a new person and said that it costs for like $90 notice for her. Yeah, but it's currently hair doesn't cost as much as like your hair does, right? So like if I do that once a year, that's.
If you have somebody, if you know the name of somebody in town that does curly hair well, let her know. She would appreciate it.
It's my hair, and I get a problem because I don't have like afro curls. I have like, so he does, so he'll wash my hair and then straighten it and then cut it. But I'm always very like, don't take that much because I know the shrinkage,
It's more than it looks like.
especially once you cut off the dead ends. This is, I learned my lesson. Yeah, so my hair is different. Wait. That's this one. It's why I'm going to school and that's learn things. So I do like Brian. I just like know to be careful. Where did you pull an H? Is the MH?
There's already an alpha carbon that has a hydrogen effect. Oh, from sodium iodide. Sodium doesn't do anything, so I'm just not drawing it as part of the mechanism.
I know, like. Gem camping is traumatized. Was traumatized, is traumatized, like I was like, what do you mean we're not balancing? I hated balancing. Carl did too, because I was always like,
balance. Siblings, units.
Yes, you want me to, you know. Oh. So then it's, hey, I'm a good sister to follow. That's true. At least I don't do a bad example. I think this is the first time we've ever been in a class together. That's true. You know, say usually I'm just after the. Like, under.
Another one?
Students, exactly. At least I'm not like that horrible older brother. Like that's true. I do feel bad for the kids that follow like a bad sibling and have to like prove themselves to not be a bad child.
You two are similar enough. You're not that similar, but you're similar enough. That it probably was pretty easy. It's gonna be really tricky for Valence because Valence is a very different person with actions.
Yeah.
They're both an acquired taste, but in different ways.
Is that it? That's the end. We're done.
That's it. There's their product. Ideally, from better, closer to scale, but
I think mine's strong first. Wait, don't raise the products.
Okay.
You can raise the products. Oh my gosh, Kathy hasn't been using the like water spray and the thing. And it literally looks like the board gets tie-dye. Like it's so bad because of some of her markers, like they just smear, they don't erase.
yeah.
It was awful. Just use the water. Does she not know about it? She knows about it. She used it a couple times at the beginning of the board, and then she just. Wait. This is two different ones.
They did the same thing twice. So after step 2. We did make a stereo center. We haven't been paying attention to stereos much.
But they don't exist.
So technically, so this is an SN2. Actually, there's 2 hydrogens on the alpha carbon. You could have used either of them. So we're not going to get any preferential stereoisomer. So just be aware that if you make a stereo center with these mechanisms, you're going to get a mixture of both. Okay. So that's after step 2. Step 3, we're going to do the same thing, except minus 78 Celsius means we have to choose between our 2 alpha carbons. Minus 78 Celsius means we get the less substituted. And now we're adding methyl iodide. So our final product is going to look like that. So really useful tool, especially if you already have a carbonyl, as a way to change the carbon skeleton in a pretty easy way.
It feels like the easiest synthesis ever.
It's really similar to the Grignard reaction, but experimentally in lab, it's even easier because you don't need to worry about the water getting in and burning things as much. Water will interfere to some extent with this, but not nearly as much as a Grignard reaction.
Yeah.
It's just a little bit more limited in that it only works where you have a carbonate. All right.
Are they close? a-
Technically, our process. But, as long as we're aware of it, I'm not too worried about that.
All right, couple more alpha carbon reactions on Thursday, but we're headed for the finish line here. So for now, we talk about, you take a break. Whoever comes back first gets to talk about their research articles first, or one of you wants to stay while the other one takes a break and then trade off.
No, break together.
Break together. Okay, I'll be here. And we'll talk about your papers.
Okay.